All right, you guys, now that we've talked about absolute value equations, we're going to change gears a little bit and talk about absolute value inequalities. So the first ones that we're going to look at are inequalities that have the less than, okay, or less than or equal to symbol, okay? We'll later look at ones that have greater than or equal to symbols, and they're going to be solved a little differently, okay? So our theorem says if A is a positive number and if U is an algebraic expression, then the absolute value of U is less than A is equivalent to negative A is less than U, which is less than A, or the absolute value of U is less than or equal to A is equivalent to negative A is less than or equal to U, which is less than or equal to A. Okay, so what it's telling you, okay, so remember when we had absolute value equations, if we wanted to drop the absolute value bars, we set our equation equal to its negative and positive answer. So if we had something like this, then we fixed it by saying U equals A and U equals negative A, okay? What we were actually doing is multiplying both sides of the equation by -1 to get that second equation. Now, when you multiply both sides of an expression by a negative when you're dealing with an inequality, it flips the inequality sign, okay? Negatives have a different effect on inequalities than they do equations. So the fix is what I call this, what we just learned, I call this the sandwich, okay? And the reason why I call it the sandwich is because if you start with an expression, as long as it's less than, okay, then what you're going to do to fix it, you're going to sandwich U in between its negative and its positive answer, okay? So that's how I remember it. If it's less than, then the fix is the sandwich. When we get to expressions that have greater than or equal to's, they're going to be a little different, okay? Now, another difference between inequalities and equations is that we are going to graph their solution sets, and we're also going to be able to write their solutions in set builder and interval notation, which I'll go over with you in case you've never seen it or you've forgotten it, okay? So let's take a look at an example. All right, so the directions say to solve the inequality, the absolute value of x is less than 4. Okay, now what I want you to do when you're doing these problems, especially inequalities, the first thing I want you to do is identify which inequality symbol you have. Because right now they're separated, but eventually when you do your homeworks and your quizzes, they're all going to be mixed up together. So you have to be able to distinguish what the fix is given the inequality that you have. Okay, so when I look at this problem, all right, I identify that I have a less than symbol. Okay, so because I have a less than symbol, the fix is the sandwich, okay? So that's what I need to remember. So what that tells me, I'm going to go ahead and write my problem. So I have the absolute value of x is less than 4. So I need to apply the sandwich fix. So you can do that once the absolute value is isolated on one side of the inequality symbol. So when I look at this, the absolute value of x is alone on the left-hand side, so I'm good. So I'm going to drop the absolute value bars, and I'm going to sandwich x in between -4 and +4. Okay, now notice nothing changed with the x, but I sandwich it between its negative and its positive answer. Now, when I have this, I can tell that I'm finished because whatever my variable is, it will be in the middle of the expression by itself. So as we're looking at this, there's nothing in the middle of that inequality except for x, so I'm good. Now we have to practice writing the answer. So anytime you're given an inequality, there's 3 ways that you can represent the answer. The first way is that you can graph the answer, okay? The second way is that you can write the answer in set builder notation. And the third way is that you can write the answer in interval notation, okay? Now, you never really have to do all 3 of these at the same time, but I do want you guys to get into the habit of being able to do either one, regardless of what the directions say. So let's go over graphing first. So if they ask us to graph our inequality, the first thing we're going to do is we're going to draw a number line, okay? And we're going to write our 2 answers on there. So our 2 answers are -4 and +4. Now you always write your numbers on there the way that they naturally would occur on a number line. So -4 is smaller, so that's why it's on the left. Okay? Now, because of my inequality symbols, okay? So the inequality symbols in this problem are less than. Anytime you have less than or greater than symbols, when you are translating that to a graph, you are going to write open circles where they occur, or you're going to write parentheses. Depending on whatever book or resource you're using, those can be interchanged. So on my two endpoints, I'm going to write open circles. The reason why they're open is because it's not equal to those values, okay? And now I need to shade my number line. So x falls in between -4 and 4, so that's where I'm going to shade, in the middle. Okay, so that would be my graph. Okay, x falls in between -4 and 4. All right, the next type of notation we're going to go over is set builder notation. So if you think about English and you think about British English, it's more proper, upscale, okay? You can think about set builder notation that way. It's fancier, it's long-winded, and it's prettier when you look at it. So anytime you're starting with set builder notation, you're always going to start with this symbol, okay? That symbol is called a brace, not a squiggly, all right? It's called a brace, and you're going to write your variable, which for us is x, and we're going to write a line, okay? Now, one thing you need to know is that mathematicians, we're super lazy. So if we don't have to write words, then we won't. We'll use symbols to do the talking for us. So what this actually means is all x such that. So we are telling our readers, or whoever's looking at our problem, you can choose whatever x's you want as a solution to this problem, such that they meet these conditions. And the conditions are the solution that we got here, that x falls in between -4 and 4, close brace. Okay, so that would be our answer in set builder notation. All right, so we have one final one, which is interval notation. Okay, interval notation is the shorthand way. It's the quickest way to write the solution. Okay, so for me, I like to think about writing interval notation like if I'm playing old school Mario. You know, the type of video games where Mario could only walk from left to right and jump up and down. None of this fancy 360 business. So when I'm writing in interval notation, I like to already have my graph, and I like to think about Mario walking on my solution set. Okay, don't laugh at my stick person. I'm not an artist. So he starts on where my solution is, and he's always going to move from left to right. Okay, so if Mario starts at -4, he's going to walk all the way till he gets to +4. So I have to be able to give him those directions. So he starts at -4. So that's where my interval notation is going to start. And there's an open circle there. Okay, open circles, like we said, go with parentheses. Okay, and then he walks all the way until he gets to 4. So comma, 4, and there's another open circle there. So parentheses. Okay, so less than or greater than symbols go with open circles and parentheses. If we ever had a less than or equal to or greater than or equal to, they would correspond to closed circles and brackets. Okay, so you know how to write your answer in all three methods now. All right, so let's try one more of these. So let's check. We are correct. Go us. All right, let's try this one. Okay, so they tell us to solve the inequality absolute value of 2x plus 4 is less than or equal to 3. So once again, we always want to look at our inequality symbol first. And in this case, we have a less than or equal to, okay, which lets me know that the fix for this problem is going to be the sandwich. Okay, so I'm going to write the problem, 2x plus 4 absolute value is less than or equal to 3. So remember, you can fix it, all right, once the absolute value is isolated. Ours is, there's nothing on the outside of that absolute value on the left-hand side. So we can drop the absolute value bars and sandwich it between our negative and our positive answer. Okay, Now remember, we're done when x is inside of the sandwich by itself. So what I'm going to do first is move the 4. I'm going to subtract 4 from everybody, the middle, the left, and the right. When I do that, I get negative 7. It's less than or equal to 2x, less than or equal to negative 1. Okay, and now I need x by itself, so I'm going to divide everybody by 2. So that gives me negative 7 over 2 is less than or equal to x, which is less than or equal to negative 1/2. Okay, so let's practice all 3 ways to write our answer, just so that we have them. So if I graph it, remember I draw a number line. I'm going to place my numbers on there, negative 7 over 2 and negative 1/2. Okay. Now, as I look at those inequality symbols, they're less than or equal to. So that means on this picture, I'm going to have closed circles. And x falls in the middle, so I'm going to shade the middle. Cool. All right. So that's the graph. The next notation that I'm going to use, remember, is set builder. Okay, when you start with set builder, you're going to put a brace. My variable is x, all x such that x falls in between negative 7 over 2 and negative 1 over 2. Okay, and our last notation is interval notation. And we're always going to think about Mario standing on our solution set. So the farthest to the left he is negative 7 over 2. That's a closed circle this time. So we're going to put a bracket. And he walks all the way until he gets to negative 1/2. And once again, we're going to put a bracket. Cool. I hope this makes sense.